Hello, my name is Bill Bates. I'm the Deputy Associate Lab Director for Environmental and Legacy Management at Savannah River National Lab. Our focus in our directorate is on tank waste cleanup, soil and groundwater cleanup, D&D of facilities, and one of the areas pertinent to this topic is the disposition of nuclear materials. I'm going to be talking about Savannah River Site and other highly enriched uranium, or HALEU, availability for use in HALEU production, primarily focused on advanced reactor use. In the early 2000s, NNSA established a project and a contract with TVA for the production of 4.95% U-235 enriched, low-enriched uranium. The EM, or Environmental Management Office of the Department of Energy, performed the operation in the Savannah River Site H Canyon. During the 2000s, the H Canyon facility produced approximately 301 metric tons of 4.95% low-enriched uranium for use in TVA reactors. The form of the material was uranyl nitrate, or a solution, liquid form, which was transported to the fuel fabricators for TVA. There is the potential to produce more high-assay low-enriched uranium, which is much in demand currently. And in 2022, the Department of Energy's EM, or Environmental Management Office, developed an amended record of decision for what's known as the Accelerated Basin De-Inventory Program, ABD as we call it. The ABD program processes spent nuclear fuel, but no longer recovers highly enriched uranium for downblending. Instead, the highly enriched uranium is ultimately dispositioned into the Savannah River Site high-level waste tanks with no recovery. If you look at the photo at the bottom of this slide, you can see the basic flow sheet of H Canyon, and this is how it used to work in the 2000s when uranium was being separated. In the current ABD program, it's basically a much simpler flow sheet, primarily without using the first and second cycle shown in that graphic. The ABD program does maintain the capability to reverse and return the capability to downblend HALEU into low-enriched uranium, or HALEU, if needed. That condition is called reversible or reversibility of those first and second cycle capabilities. Currently, based on current inventory and projected inventories, the Savannah River Site could produce between 12 and 20 metric tons of 19.75% enriched HALEU, depending on whether natural uranium, low-enriched uranium, or LEU+, which is generally up to 10% or 9.75% enriched LEU, to produce varying levels or varying amounts of HALEU. There are some timing challenges. It's not able to be reversed or brought back online right away. It will take a number of years and some costs to return those systems to service. A lot of corrective maintenance and preventive maintenance would need to be brought back online. There's also some flushing and some equipment replacement that would need to be done if a decision is made to return to downblending. The Savannah River Site M&O contractor and the Savannah River National Lab are currently working to produce approximately 4 metric tons of HALEU from existing stocks of material that was dissolved with HALEU recovered and downblending performed prior to the amended record of decision, where all of that separation stopped. The 4 metric tons should be produced and available in approximately 2027-2028 timeframe. The picture below shows the H Canyon facility from the inside. There are some opportunities around this topic, and I'll start with the fact that SRNL led and issued a study back in the year 2020 known as the TBD study, or To Be Determined study. TBDs refer to nuclear materials with no identified disposition path, as documented in the NMIA, or the Nuclear Materials Inventory Assessment. Some of those TBD items are highly enriched uranium items with the potential to be downblended to produce HALEU. Recovering the HALEU and downblending it to HALEU, or HALEU, has multiple benefits. First, providing fuel feedstock for advanced reactors is a critical value for that HALEU. It's not seen as a permanent solution to the problem, but it could potentially be a bridge until enrichment capability is up to scale and producing throughput that can support all of the advanced reactor demand. Second, it helps de-inventory the DOE sites where the HALEU is stored. Storage is costly, vaults and vault security is also costly, and vault space is very limited. So all of that would be a benefit to the DOE sites where the HALEU is stored. Third, it dispositions the nuclear materials with no identified disposition path, or the TBDs, as I mentioned. So the goal is to reduce the number of TBDs owned and managed in the DOE complex. And finally, maybe the obvious one, by reducing the TBDs and dispositioning excess nuclear materials, we reduce DOE's out-year liabilities. All of this effort to take advantage of excess nuclear materials and use it for beneficial good uses is consistent with the NA-ESH 12 Nuclear Materials Integration Division themes of seeking disposition paths for excess materials, and secondly, if possible, finding those beneficial reuse opportunities for those materials across the complex. So the current situation or status today is that demand for HALEU exceeds the current HALEU supply, particularly for advanced reactors. Numerous new companies are trying to find sources of HALEU to meet their demand for their mission, for their business case, for their mission going forward. Savannah River Site's HALEU scope uses the last HEU that was recovered in the H Canyon from reprocessing, or basically recovering, HEU prior to the amended record of decision that stopped recovery. The effort to recover and produce HALEU from that material is sponsored by the DOE Office of Nuclear Energy, and it involves a number of things. H Canyon has a number of upgrades, preventive and corrective maintenance activities to bring their downblending capabilities back into service at the Savannah River site. And Savannah River National Lab has performed an extensive suite of analyses on a number of samples from all of the solutions in H Canyon that will be used to downblend to produce that HALEU. A shipping package safety analysis, or a SARP, is being revised to allow shipment of this HALEU solution offsite to a fuel fabricator for an advanced reactor company. The graphic on the far right of the LR230 trailer and the LR230 containers is the container that we plan to use to ship that material offsite to a fuel fabricator. SRNL is leading the work, working with an offsite vendor to perform that SARP review and get that package licensed and certified to be able to use it for this purpose. In addition to that, some studies are underway to look at how to stretch the HEU to make more HALEU than it normally would. And what I mean by that is that the baseline case is planning to use natural uranium to downblend and produce that roughly 4 metric tons of material. SRNL is looking at what could be done to use low enriched uranium, or perhaps even LEU plus at a 9.75% enriched uranium, a U-235 enriched uranium, to produce more HALEU than the 4 metric tons. The SRS M&O contractor is supporting that study, and we expect that to be finished sometime in May of 2025. There is additional HEU at SRS and across the DOE complex if there is additional interest, funding, sponsorship, and interest in making more HALEU from that material. I'll run through these quickly. The first group is the Savannah River site spent nuclear fuel. A lot of highly enriched uranium in that spent nuclear fuel. It is EM-owned and managed spent nuclear fuel. Idaho National Laboratory also has spent nuclear fuel, much of which contains highly enriched uranium, some owned and sponsored by the Department of Environmental Management, some by Nuclear Energy. There is some unirradiated and very low burnup fuel and HEU, which is beneficial in reducing the amount of impurities and the dose rate on the potential HALEU that could be produced from that material. Some of it is at the Savannah River site, some at other sites. Some of it is loaned material from the Department of Energy to other organizations, such as the White Sands Missile Range material handled right now by the Department of Defense. There's also some programmatic use material that is not yet declared excess. An example of that would be the Sandia Pulse Reactor number 3, or SPUR 3, as we call it. More difficult to access and recover the uranium, there are some other mixed forms of nuclear material. An example would be PUEU, or plutonium mixed or blended with enriched uranium, that could potentially be separated to recover HEU for downblending. The main challenge today is that there is not the capability, or at least not the capability with significant capacity, to be able to process and recover large quantities of this HEU. Things like Canyon would have to be brought back to service to be able to make meaningful, sizable recoveries of bulk HEU to produce meaningful amounts of HALEU. We recognize that some additional HALEU is being produced at Idaho National Lab from the EBR-2 spent nuclear fuel, and that plus the SRS material are two of the primary sources currently for the advanced reactor community. And as I mentioned, there are some considerations for bringing back Canyon for recovery, but no such decision has yet been made, and it is currently under study.